Hello everyone, welcome to your next class. Today we're going to be talking about another histogram type. We're going to be talking about bar plots, and we're going to introduce more about standard deviation and variance into this lecture so that you understand how to build a full bar graph. One unique feature of bar graphs is that you can plot variance very easily on them, and most uh, journals or any kind of academic publication or even research for a company will want to know that kind of information when you plot a bar graph. So we're going to get a reintroduction of that and also look at why bar plots are interesting and what makes them different, why you use them in certain cases and not others. Okay, so let's just get into it. So we're going to understand when it's good to use a bar plot, when it makes sense to use one histogram type over another. We have a scatter plot that we've talked about before, but bar plots can do very specific things very well. So we're going to show you what makes bar plots unique and why you should use them for certain cases, and assessing when those times are when you see data that you need to be visualizing. So a bar graph is a histogram that shows ordinal or nominal data, usually as the x-axis, which is like a category or a label, and there's some sort of interval or ratio quantity as the y-axis. That's the dependent variable. So usually it would be things like, kids under 20 or over 20. Those are two categorical, like ordinal or nominal variables, depending on how you collect that data. And then you might have proportions, or like 30 kids and 30 adults as the y-axis, where the bar is kind of growing. So that's basically what a bar graph is. It's a histogram that uses the ordinal or nominal data as on the x-axis. So we're going to go over the syntax of a bar graph, and then we're going to hop into Python and build a bar graph from matplotlib. We're not going to use the syntax portion to go through that. We're just going to show it to you in a Jupyter notebook. So let's go into it. Okay, guys, so here we are. We have our bar graph here. This is an example of a bar graph. You'll notice on the x-axis we have nominal categories A, B, C, D, and we have these. This is actually this shows multiple information. This is not a stacked bar graph, but a bar graph that is positioned next to each other. So this is showing two sets of information, showing group A and some score for men, which would be around 20 here, and for women in group A would be about 25 in this case. In group B, you're seeing 35 as the total for men, and it looks like about 31, 32 for women in group B, and so on and so forth, okay? So the x-axis is our nominal or ordinal independent variable right now, okay? Our y-axis is score. So this is an interval, this is ratio, because a score of 0 is a true 0. This is ratio data that it's showing, and it's like maybe average scores or something for a bunch of groups, right? So there's probably more than one man and one woman. Also, actually it has to be, because that's what these things are representing. These bars represent so this is actually representing the average score for men in group A, 20, and this bar is representing the variance from that average. So it looks like the variance is 1.5 for this group, and you'll notice that it's smaller in this case and much larger in this one. So this is showing very different variances for different groups. So we know what our y-axis is, right, guys? It's our dependent variable, and we know that our groups are our independent variable. But I hope you can see now how this information is not necessarily easily plottable in a scatter plot. Where's the if this was the y, the y Cartesian plane, how do you label this as in the Cartesian plane? You go 1, 2, 3, 4, but that's probably not really representing what you want it to, obviously. Okay, so let's go into the code and see how we make this. Okay, we're gonna make a simple one, and then I'm gonna show you how we built that more complicated one. So first off, we load our packages. We're gonna use NumPy and Matplotlib. I'm creating an object or a list rather called objects, or we can call it languages. Here we are. So these are a bunch of languages, and then this is the performance score. I don't know, someone's saying how or some value is establishing like how good this language is for some task or from usage most people are using or something. This is made up data, guys. And so we have these two lists. It's really just plot.bar. You give it the x first, which is your ordinal position. You give the performance, which is your y. That's the scores for each of these in the same order. So Python is 10, C++ is 8, and so on. We then add a .y label. So this is like changing the label for this plot to usage and changing the title here, and then we show it. Notice how we didn't do subplot here. You can do just like a regular plot like this for like simple plotting if you just want to get your figure out there to see what's going on. But it's usually best to use the subplot feature because you do get the you can manipulate it a little bit more. You have more control over what you're showing. Okay guys, next I'm going to show you how we built that other plot, the one that we looked at our syntax with. This is an example from the internet. So I went on something like Stack Overflow or Stack Exchange and just found some sample code that showed what we wanted to show and then tweaked it a little bit. So I'm going to go through this one step at a time with you guys though, so it shouldn't be that bad. We load in some packages here, just standard initialization stuff. You will see when they all come into play, so don't worry about that. First thing we do is this is what's going on here is that we're establishing variables. This is kind of like common practice in coding, where you when you're like at the beginning of your code, you usually have an area where like you build all your global variables that you're going to be using for the next little bit. You keep everything organized, and so that's kind of what's going on here. We're creating groups. We're creating how many different bars they're going to be, or sets of bars they're going to be. And we actually made two different bar plots. We had the positioned bar plots. They weren't stacked on top of each other, but they were positioned next to each other. And so how we built that was we had to create some fake data. So this is some data that we just kind of made up, and it's manually input. All right. And we have these are fictitious means and standard deviations. That's what these are, okay? And so what we look at here when we plot this, so first thing we do is we build our objects, we build our figure and axis objects, and then we set some indices. What this is doing is just kind of creating a range of numbers. It's an array range. So it's a data type that NumPy uses a lot, and we're creating a number like 1, 2, 3, 4, 5. That's basically what we're doing with this index, guys. That's what this is. It's a list that has index numbers, okay? We create a couple of more variables, which is how thick we want the bars to be and what the opacity is. We'll play with these a little bit, and I'll show you what that looks like now. Well, I'll show you what it looks like after we go through this entire code, okay? So first, we create one of the bar plots. First, we create the blue bar, okay? So how we do that is we say access, and like we say .bar, and that will add a bar object to our axis. It'll create a .bar object, basically. And we save that to rectangles1 or rex1. We pass in the .bar parameters. If you go to the documentation, it'll show you what you need to pass in first. So it wants to know like how many groups, the means, what is the actual, the values, I guess. This would be y. and then it wants you to put in how wide the bars are. So we just had this as a global variable because we want the bars to be the same for both. Then we give it the opacity. That's what alpha means. Alpha is opacity. And then we give the color parameter, which is blue. We just say blue here. And we give, this is the error when we want to put in the standard deviation. So we say then we give it the standard deviation list. And this is all in the same order, right? So like everything is, all these lists are positioned exactly the same, so that the first value for our means is also the standard deviation for that value. And that creates that bar. That creates that bar plot. Okay? And then what we do is we create the other bar. And it's almost like completely identical, except this is different now. The means for women instead of means for men. The color is red, and we have the standard deviation for women. And we have the label that's different as well. Okay? So when we build all of that, let's just like look at that without anything else and see what happens. And we'll play with the opacity a little bit too. So that's what it looks like when it comes out like that. Okay? Let's play with the bar width a little bit. Let's put it up to 5. Okay, so the bars are now so thick that they're touching each other. So that might be a little bit too much. We could probably build in some parameter that adds padding or spacing between them, so it would be a lot more horizontal, but that width seems to make sense. Let's also increase the opacity now and see what happens. So now it's a lot darker. See how it went from like kind of like a much more pale? Let's see if it goes more pale than that. Yeah, see how the opacity is getting clearer and clearer? That's what the opacity does. Okay, so then all we're doing here is we're adding the X label, which was group, adding the score, we add the title, we're setting this all from the access object, we're setting the ticks, so this is telling us how far we want these things to go. So now let's do this again, see the bar width, and we'll put this up to 5 and see if it spaces out properly. Not quite. Okay, I thought maybe it would work, but no, it's not exactly doing that. Okay, so then we just make the labels, and how we make the labels is we pass through a list or a tuple, and this is, you know, all the group names, and then we give it a legend. And then this just kind of like sets everything in the figure to be tight together, and then we plot. That's like line by line what's going on here, guys, and like and you can kind of like if you ever are questioning what's going on here, I hope I've shown you enough tools to like let you you know, read more about it and figure out what I need that's missing from this. Like, okay, so I'm building my own graph and I'm, you know, coming across this thing that's slightly different, so it's not coming out the same way. What do I need to fix in some of these parameters in order to make that correction? And that's what I'm hoping you're getting from this. So that is how we create a bar plot. All right, guys? So with that in mind, let's just do a recap. Today we did more plotting. We learned how to do bar plots. We learned about standard deviation in bar plots and why it's a useful type of graphing method, especially when you have ordinal or categorical data. We also learned a little bit about how to do kind of advanced styling in Matplotlib. A lot of that stuff was fairly advanced. So although not all of those functions might necessarily work for your scatter plot or your line graph, you should start to be. I'm hoping it like turns on some light bulbs of like, okay, well, this is how I would go about finding what I want to get it to work. So okay, guys, thank you very much, and we'll see you next time.